Okay, so this is the video lesson for 4.3 Laws of Logs, and as you notice, there are several rules here, so let's kind of unpack these. This should be review from Algebra 2. So if you have a log, base A, and this could be natural log as well, of a product, x times y, that is going to equal the sum of the two logs individually. So it'll equal log base A of x plus log base A of y. Again, this is the exact same rule as saying natural log of xy is equal to natural log of x plus natural log of y. Okay? The log of the product equals the sum of the logs. All right? Very similarly, just like with exponential rules, you have this correlation between adding and multiplying. You have it with logs as well. So if I am taking log of a quotient, x divided by y, it will equal the difference of the two logs. And again, this would be the exact same thing as saying natural log of x divided by y is equal to natural log of x minus natural log of y. Okay, this last one we've actually seen before. This is about powers of log's argument. So log base A of x to the power of k, that is equal to k times log base A of x, meaning the exponent on the argument of the log is now can become the coefficient. And so this would look like natural log of x to the power of k. That would equal k times natural log of x. Okay, these are very important rules to have, and you need to know these rules. This is something you will for sure be using in calculus, and they really won't have time to review them. So you learned it last year, we review it this year, we know it really well, so you're good to go in calculus. And then the last statement may seem a little bit obvious to some of you. If log base A of x equals log base A of y, then x equals y. And this goes both ways. All right, this can be considered an if then or then if. The inverse is true. If x equals y, then you can take log of both sides, and the statement is still true. The reason you can do this is because it's a one-to-one function. If it's not one-to-one, then this might not necessarily be true. Okay, let's go work some examples now. How can I actually apply this? So you may remember this from last year. Sometimes you're expanding logs, sometimes you're condensing them. It's important to know how to do both ways, that way you fully understand it, although the condensing is the more important part. So when we have this expanding, what we need is to break up this product. All right, now notice that this is log base 5, so everything I write needs to be log base 5. Okay, so the first thing I may want to write is log base 5 of x cubed, and then plus log base 5 of y to the 6. Notice that it wasn't times, all right? The rule is that we need to add these two. Now look, I have exponents. I need to move those down to be coefficients. So 3 log base 5 of x, that's what that first term turns into, plus 6 log base 5 of y. Okay, so that's how you expand. On this next one, we have natural log. So let's go ahead and write all this out. We would have natural log of A plus natural log of B. So that's the easy part. Now I'm dividing, so I need to subtract the log. Minus natural log of C minus natural log of square root of D. Now, do you think you can go any further here? Square root of D is the same as D to what power? The 1/2 power. So my final answer is going to be natural log of A plus natural log of B minus natural log of C minus 1/2 natural log of D. Okay, now let's condense. Notice that these are all natural logs. That has to happen in order to condense. They all have to have they all have to have the same base, their log. And when they're natural log, they do have the same base, E. Okay, probably a good first step here would be to go ahead and write these as just log of something. So if you have a coefficient, writing it as the exponent. And then the same thing here. I'm going to go ahead and write this as square root of B. Now here I notice that I have a coefficient on a term. Do you think you can break this term up? Nope, this is natural log of this term. There's no rule about that. If this was x squared times something, I could do something with that. But this is just going to be minus natural log of the quantity a squared plus 1 to the power of 4. And then minus natural log of c. Okay, the minus natural log, those arguments are going to go in the denominator. So the next step, you're going to write one natural log. You're going to write a big statement, but only one log. Condensed means one log. Okay, a cubed, square root of b, go in the numerator. And in the denominator, I have a squared plus 1 to the 4th power times c. Now, just for convention's sake, I'm going to put c first, since it's a single term. And there we go. And there's lots of reasons why this might be more helpful to you. Definitely using one log instead of 4 separate logs, that can be helpful if you were doing something else with this problem, which you will next year. Okay, so let's look at this evaluating one. Now, using what we learned yesterday, we could evaluate these two things separately and then just subtract those two numbers. But 2 to what power equals 80? I know that 80 is not a power of 2. So the best I could do here is estimate what these two numbers are and then subtract them. My next step would be then to use the calculator. But actually, if you know these log rules, these log properties, you can get an accurate answer without the calculator. So the first thing we would want to do is condense it into a single log base 2. Now, since this is log 80 minus log 5, that's going to make our argument become 80 divided by 5. And what is 80 divided by 5? Okay, so that's 16. So we have log base 2 of 16. And now 16 is a power on 2. 2 to the 4th power equals 16. And even if you didn't know that, you could figure that out just by kind of thinking of the powers of 2 in your head. 2 cubed is 8, so 2 to the 4th would be 16. All right. In the next lesson, I'm going to talk about what to do when it still doesn't work out. Like what to do if this 80 over 5 had been 90 over 5. Okay, we'll get to that. But for now, you can still do these accurately without the calculator. Okay, here we have kind of like a formula. Maybe this is derived from something where P and P naught or P sub 0 are pressure, both initial and final, and T is the temperature, and C is some other constant. Who knows, okay? That doesn't really matter for what I'm asking you to do. I'm asking you to solve for P. So I want to get P by itself. All right, so the first thing we can do is just get a single log on the right side. If I can get a single log on the right side, then I can use that statement that log of P equals log of something else, then I can write what P is equal to. So first thing on this right-hand side, what we want to do is we want to move this coefficient to become a power. And I think as you practice this, you'll be able to do all these things in one step, but I'm going to make sure that everybody understands how this is going. Okay, now let's write this as a single log. So I have P naught, or P sub 0 on the top, and then I have T plus 1 to the power of C in the denominator. So now P has to equal this expression right here. Now you have maybe a good formula, but now solved for P. And that may be more useful to you because that's what you're solving for most of the time. And from here, we could easily change it to where we were solving for P sub 0 instead of P. It doesn't matter. It depends on what you were actually using this for. Okay. Let's look at this problem. Find the function of the form y equals log base a of x that goes through this point. Anytime you're given a point, really all they're doing is they're giving you an x and giving you a y value. You don't have to try to graph this in order to figure it out. But here, algebraically, is actually easier. So we want to substitute the -1 in for the y value. We don't know what a is. we want to substitute 1/2 in for x, and if you notice, now a is my only unknown. So I can just use what I know about logs and exponents in order to find out what a is. Okay, so if I rewrite this as an exponent, I would write a to the power of -1, and that will be equal to my 1/2. This just goes back to that first time we saw logs, where we go from log equation to an exponential equation. Okay, this is more comfortable to work with. So you can either think now, what number, when I take it to the -1 power, gives me 1/2, and that is 2. But I'm going to show you something else that can definitely help, and then we'll write our final answer. But let's say you really just weren't sure what to do here. You have a to the -1. You can take another power that will cancel out the -1. That will make it a +1. Well, in this case, that's another -1. But I have to do it to the other side. I have to take 1/2 to the -1. So you can take both sides to a power. All right? That gives me a to the +1, and then 1/2 to the -1. Maybe that's a little bit easier to do. Now in this case, I really think it was probably easier just to figure out what a was logically, but you have options there. All right, now that I know what a is, I can actually find the function of this form. Okay, so we can write it as f of x or as y. Y equals log, not base a, but base 2 x. So the log base that goes through that point is log base 2 of x. And I think that was our last problem. It was. Okay, so bring your questions to class. You should be able to do all of this without the calculator, and I'll repeat that in class tomorrow.